In the last video, we were converting between moles and particles. Particles being atoms or molecules. In this video, we're going to go opposite. We're starting with a quantity of atoms or molecules, and we're converting it to moles. We're using this proportion method, where we start with what we have. Let's see here, 3.87 times 10 to the 23rd atoms of tungsten, which is kind of goofy, but its symbol is W. It's based on like an old English word. Then I'm going to set up my proportion. I want to cancel the original atoms. I want to switch it to moles. Atoms and moles. I always set up the proportion first. I put the units in, and now I can give it the numerical values. 1 mole of anything is 6.02 times 10 to the 23rd atoms. So I suppose I could say 1 mole. Look at that. All right, my units are set up so that they cancel. I like that. Makes me happy. I've got moles on the top where I want it. Atoms on the top and atoms on the bottom will cancel. So the only unit I have left is the one that I want, moles. Now with the number being on the bottom of my proportion, I would divide. But if you want to make this a little easier on yourself, you've got 10 to the 23rd on the top divided by 10 to the 23rd. You could cancel that too. So really in your calculator, you could just go 3.87 divided by 6.02. And for sig figs, I just go back to the original. The original number given has 3. So I'm just going to leave 3 as my final answer. 0.643 moles. And I can see if this makes sense. 3.87 times 10 to the 23rd is a little more than half a mole. Half a mole would be 3 times 10 to the 23rd. Yeah, my answer, a little more than half a mole. It's great. You set all of these up the same. That's the beauty of it. Don't try to memorize anything. Get this unit conversion method hammered into your brain, and you can apply that to any situation. I start with what I have, atoms of cesium. And you have to put the unit in. Sometimes people will say, I don't get this, I'm not getting the right answer, I don't know how to start these. If all you do is put the number down, I don't know how to set up the proportion. You have to tell me, what is that 1.63 times 10 to the 23rd? Oh, it's atoms. Because then I'm putting atoms on the bottom of my proportion, so they cancel. What I want goes on top. Then I can put in the conversion. 1 mole is 6.02 times 10 to the 23rd atoms. Not only do my units cancel, atoms and atoms, but again, you can cancel these 10 to the 23rds, make it a little easier to put in your calculator. My original has 3 sig figs, so I'm going to leave 3.271. I went 1.63 divided by 6.02. Piece of cake. And again, this kind of makes sense. It should be a little bit less than a third. A third of a mole would be 2 times 10 to the 23rd. I have a little bit less. Oh yeah, I have a little bit less than a third of a mole. My number is reasonable. You can do the exact same thing with compounds. This is great. 2.008 times 10 to the 23rd molecules of butane. And so again, you might kind of remember bute, the prefix for 4 carbons. Ane means they're single bonded. So to get the formula, I might actually have to go around and draw this I'll fill in all the hydrogens, giving carbon 4 bonds. Hydrogen, hydrogen, hydrogen. C4, H, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then I set up my proportion. I want molecules to cancel. I want to switch it to moles. You can say mole, MOL, MOLE. The ratio is the same. 1 mole of anything is 6.02 times 10 to the 23rd particles. This time the particle is a molecule because my original is a compound, butane. Did it matter that it was butane? Did I really need to draw that structure? No, I really didn't, but it was kind of fun. That relationship between moles and molecules, that is irrelevant to the identity of the particle. 1 mole of anything is 6.02 times 10 to the 23rd particles. So again, every single one of these was the exact same setup. It didn't matter what the identity of the particle was. When I plug this into my calculator, I'm also going to cancel the 10 to the 23rd. Now this time my original has 4 sig figs. 2.008 is 4 sig figs. So I'm going to leave 0.3336. And is that answer reasonable? You betcha. 2 times 10 to the 23rd is about 1/3 of a mole. That's exactly what I got, about 1/3 of a mole, 0.333. So again, at this point, I think I would pause the video and try numbers 4 and 5. Obviously, they're going to be very similar. Bring it back, check the answers. If you're getting these right, you're in a really good place. All right, so here are the last two, 4 and 5. Number 4 is a little bit tricky. I have my 9.06 times 10 to the 24th molecules of sodium hydroxide. I cancel molecules, switch it to moles. So again, the proportion every single time was the same. The only bummer is that it's not 10 to the 23rd. So when you plug this in your calculator, yeah, I know that I have it set up right. Molecules and molecules will cancel. But you really can't cancel 10 to the 23rd and 10 to the 24th. Now you can make this easier on yourself if you understand scientific notation. You could plug this in as like 90.6 divided by 6.02. The original should have 1 extra power of 10 or 1 extra decimal spot. So you could do that if you want to just make it simpler to plug in your calculator. Or just plug in the scientific notation. Again, when I do this, I would highly suggest plugging it in as 9.06, then hit your EE key, and then just 24. Your calculator knows you want it to do scientific notation. So I can plug in 9.06 EE24 divided by, and then same thing here, 6.02, then hit your EE key, 23. That should give you 15.0 moles. Which again, I used 3 sig figs because the original 9.06 had 3 sig figs. In scientific notation, your significant figures are what's left out in front. Similar issue with number 5. 1.00 times 10 to the 24th molecules of mercury oxide. And again, through the whole thing, I didn't have to write the formula for mercury oxide. It's kind of irrelevant. It's not going to change my ratio. 1 mole of anything is 6.02 times 10 to the 23rd particles. But I just had fun writing it, so I did anyways. So again, you have 1 times 10 to the 24th molecules. So while you know you have it set up right, because molecules and molecules will cancel, you can't really cancel the 10 to the 24th and the 10 to the 23rd. You could simplify it, and you could plug it in as like 10.0 divided by 6.02, or just plug it in your calculator. And now these are the ones where if you're not going to use the exponent key, if you are obsessed with the caret key, you'll probably want to put those two quantities in parentheses so that your calculator does order of operations correctly. We want the quantity 1 times 10 to the 24th divided by the quantity 6.02 times 10 to the 23rd. So I'd highly suggest plug some of these in your calculator so that you know you're using your calculator correctly.